Determine the support reactions for the beam shown in figure. This is triangular loading. This is trapezoidal loading. Trapezoid consists of this rectangle and one triangle. And this is roller support and this is hinged support. For roller support, one reaction VA, and for hinged support, there are two reactions, one vertical and one horizontal. Simplifying this triangular loading, area of triangle will be half 20 into 6. So it will be 60 kilonewton acting at 6 by 2, 3 from this or 3 from this side. So it will be acting at this point B. Now simplifying this rectangular loading and this triangular loading, this is 10 and this is 10 and this will be 20. This is 10, so this will be 10 and this remaining this total is 30, so this remaining will be 20. Area of triangle will be half this 20 into this 5. Area of rectangle will be 10 into this 5. So for triangle, single point load of 50 kilonewton, that is half 20 into 500, 20 into 500 by 2, 50. It will be acting at 2/3 from the apex. 2/3 from the apex, that will be 2/3 of 5 will be 3.34 meters from apex, or from base 1/3 of 5 it will come to 2.67 meters from base. And for rectangular loading, single point load will be 10 into 5, 50. It will be half the 5, 2.5. It will be acting at half of 5. From C, 5, 2.5. From D, 2.5. So 50 kilonewton force acting at 2.5 meters from this point or from this point. So now resolving forces horizontally, there are no only single horizontal force HD and there are no other horizontal forces, so HD will be equal to 0. Now resolving forces vertically and equating to 0, that is summation Fi equal to 0, VA VB plus VD minus 60 minus 50 minus 50, VB plus VD minus 60 minus 50 minus 50. So VB plus VD equal to 160 kilonewtons. Taking moment of forces about B. VB force passes through point B, so moment of VB about B will be 0. 60 kilonewton force passes through B, so moment of 60 kilonewton about B will be 0. 60 into 6, 0, 0. Moment of 50 kilonewton force passes through line of action of force like this, and it will have perpendicular distance about point B of 5.5 meters, and it will rotate about point B clockwise, and it will have magnitude of moment of 50 into 5.5. So 50 into 5.5 clockwise. So moment of 50 kilonewton force about point B will be, it passes through point line of action of force like this. It will have perpendicular distance about point B of 3 plus 3.33, 6.33, perpendicular distance from B to 50 kilonewton force, 6.33. It will rotate about point B like clockwise, and it will have magnitude of moment of 50 into 6.33. And this HD force passes through line of action of force like this. It passes through point B, so it will have zero moment about point B. This VD passes through line of action of force like this. It will have perpendicular distance about point B of 3 plus 5, 8 meters. It rotates about point B anticlockwise, and it will have magnitude of moment of Vd into 8. So we have resolved forces horizontally and equated to 0. We got Hd equal to 0. We have resolved forces vertically and equated to 0. We got Vv plus Vd equal to this equation, and we taken moment of all forces about point B and equated to 0. We got Vb value. We substituted Vb value in this equation. We got Vd value. We got Hd value. We got Vb value and Vd value. To get Rd value, substitute Hd Vd value. We get Rd value